Okay, so now to see the benefit of this, the int pointer, of using this typedef, I'm going to show you in the next two examples how we can actually pass pointers using call by value and call by reference. This is also a nice little review because you're going to be using call by reference and call by value are two of the things you have to know for the first test next class. So if we want to actually, let's just create some function here. And typically, what do we do to create a function? If we're creating a function, we declare it before the main usually, and we define it after, right? So we're going to just declare some function. Let's call it void my function, okay? And I'm going to pass it an int pointer p. Let's call it p2. So that's, I'm declaring it. Now, if I was doing this instead, if I had to, if I didn't have an int pointer, this is just the same as doing int star p2, right? Because remember that what I mentioned about the typedef is really just sort of like a find and replace. So this is really just the same as doing this or doing this. So one of the benefits of the int pointer using that typedef allows us to sort of pass this as a call by value without having to worry about the star operator. Yes, Jeremy. Say that again, sorry? You could. We've seen that already, right? That's a call by reference. Okay, that means it's a reference to an address of an ordinary variable x. We would pass it the address. Now, what we're doing is we're doing a call by value parameter for a pointer. But of course, what's the value of a, what does that actually pass? A pointer actually stores what? An address. So this is actually going to have an address here. And let me just show you here. And what I'd like to do is just to show you this. Let's continue with this and let's do the body of this function, the definition. Okay, and what I want to do here is, in this one, I'm going to create another integer called x. I'm going to equal it to 5. And I'm going to say here, I'm going to assign to p2 the address of x. Okay? Now, let's display out the value of p2 here. If we want to display out p2's value, we can do it this way, right? Star p2 is how we get the value, isn't it? This is really just the same as this code right here. I'm just writing it out because I noticed some people commented that sometimes when I cut and paste quickly in that, they lose track of what I'm doing if they look down for a second. So I'm making a point of trying to write out the code instead. So this is the same thing as what we did up there for P1. We're going to display out the value of P2, and we're going to display out the address of P2. Great. Now, do you want to display out x as well or no? Should we display out what x is just so we know, or do you care? What? Well, here's the question for you. What do you expect P2 to equal and the address of P2 to be here? Well, that's what I'm asking. Well, what I'm going to do is I'm going to give each of you a second to try this out. Okay. I prematurely asked you guys to actually run this code because I forgot that we didn't actually call the function, which sort of is important. So we're going to call the function right here. And we're going to pass into the function p1. Okay? So that's what we're going to do. So what I'm asking you is, we've seen already that p1 and t here were both the same when we first ran this. But now we're passing the pointer here, and we're doing this. So p2 here, what will the address of p2 be? Well, just to be sure, let's actually, I'm going to put out this cout line for x as well, just so you guys see everything. the value of x and the address for x okay. So let's actually run this and try it. So what we have here is we basically have taken the program that we used in the last example, but before we display things out, we're calling this my function and passing the pointer into my function. So really the question is, when we pass in the pointer here and we assign x, we make the pointer instead now point to x, what will this end up changing the stuff outside, and what will be the values in here? So let's actually run this and see. So we're going to run pointers example 2. We're going to compile it first, and then we're going to run it. And the first thing, now we're getting the x in P2. This is the new stuff because the function was called first. So we're seeing that x's value is 5, which is what we expect because on this line right here, line 30, we can see that x equals 5. That's what we initialized it to. The address of x, we have a whole big memory location here. Then we assigned on this line 31, we said P2 is going to point to, or it's going to equal the address of x. So in fact, yes, when we actually look at the address of P2, it's the same as our address of x, isn't it? These numbers are the same? And the values are the same too because they both point to the same memory address. Now, the thing about this is that after this function is over and we come back out here, P1, here, we actually did this as call by value. So we passed a copy of the address that P1 points to. We didn't actually pass the address of P1. So when we changed it here, the original P1 still points to the same address and the same value. So I'm going to just, before we move on further, just so everybody understands, I'm going to draw that out, walk through it on the board with the memory so you can see what's actually happening here. And I'll put this on the course website.